Okay, in this class, we will try to highlight on the different types of chemical changes. That is, different types of chemical reactions. In the previous class, we have just got a concept on chemical changes and we have classified the several characters of a chemical reaction. We have come to know that in a chemical reaction, the gas may be evolved. In a chemical reaction, the color of the substances may be changed. In the chemical reaction, the energy change may occur. So today, first we will highlight on the different type of chemical reactions and then we will highlight each of them individually. So first of all, we are trying to highlight the different types of chemical changes. Well, the different type of chemical changes can be classified into 9 different wings. That is the direct combination, number 2, decomposition, number 3, the reversible reactions, number 4, the thermal dissociation, number 5, displacement, number 6, double decomposition, number 7, isomerism, number 8, polymerization. So these two type of reactions are not directly involved in our syllabuses, but still we will get a regular concept on this. And number 9, that is redox reaction, and trust me, the redox reaction is the most important according to our syllabus. So here we start. The first type of reactions is known as the direct combination or synthesis. Basically, in such type of reaction, two different substances or elements are going to be react chemically and form a single substance as a product. So imagine we have A and B, two different substances or elements, and they are going to be joined chemically and form AB. So this is the generalized formula. Now we will try to follow a certain chemical reaction. Imagine we have carbon and oxygen. So carbon is going to be burned in presence of oxygen, where carbon is nothing but a substance and oxygen is not but a substance. So right now carbon and oxygen are going to be joined chemically to form carbon dioxide. And such type of reactions is known as direct combination of synthesis. And most important, in synthesis process, single substances are going to be formed. So this is a single substance. And we will find different type of examples over here. So if we burn carbon monoxide in presence of oxygen, obviously we need to follow the balanced equation to protect the mass conservation law. Then we will find carbon dioxide. So it is also type of synthesis, right? Again, we will find if we react ammonia in presence of HCl, that is hydrogen chloride. So if we react ammonia in presence of hydrogen chloride, then this will be NH4Cl, that is ammonium chloride will be formed. So this is also such type of reaction where one single substance is going to be generated. And remember, this last reaction is very important because ammonia is a gas, HCl is a gas, because we have termed this as hydrogen chloride. So hydrogen chloride is a gas and ammonium chloride is a solid. So two gases are going to be reacted in chemically and form a solid substance. This is very important in the such type of reaction where we have just discussed on the topic of direct combination or synthesis. In synthesis process, we will find more examples. If we burn any active metals in presence of oxygen, this will form metal oxides. That is, magnesium is going to be burned in presence of oxygen. This will form magnesium oxide. This is also a certain type of example of synthesis. Again, if we combine water with carbon dioxide, then this will be H2CO3. This is also nothing but an acid. So in such way we can form acids too. Again, if we try to produce H2SO4, then we apply oleum, that is H2S2O7 in presence of water. So this will be nothing but sulfuric acid preparation process. So over here, oleum and water is going to be recombined and prepare H2SO4. This is another type of direct synthesis process. Fair enough? Okay, to be very honest, the decomposition reaction is just the reverse process of the synthesis or direct combination, because in synthesis process more than one substances are going to be added up and a different type of compound substance is going to be formed. But here in decomposition, one substance is going to be splitted, or one compound is going to be broken up into two or more simpler compounds or elements. That is the exactly logic if we follow the generalized reaction, that is AB is going to be broken up into A and B, where A and B individually are the simpler compounds. So the very interesting part of this, in most of the cases of decomposition, we will use heat, and we know in the reactions where we use the heat, this is nothing but the endothermic reactions. So all the endothermic reactions in most of the cases are decomposition reactions. We have just observed that calcium carbonate, if it is going to be treated with heat, then we will find this will form calcium oxide and carbon dioxide. So this is a very good example of decomposition, and as here is the heat is involved, so such type of endothermic reactions are known as the thermal decomposition. Basically, if the endothermic reactions are going to be broken up the main substance into two or more simpler compounds, then those type of endothermic reactions will be treated as thermal decomposition. Again, we will find if we treat mercuric oxide in presence of heat, it is nothing but another type of endothermic reaction, then we will find that liquid mercury and oxygen gas is generated. So this is another example of decomposition. But not only the heat is involved, sometimes the current electricity is involved in such type of reactions, where if we follow the electrolysis of water, then we will find that the water is going to be broken up into hydrogen gas and oxygen gas. So in such type of process, obviously current electricity is responsible for the decomposition reactions. Again, similarly, some enzymes are also responsible in human body to perform such type of reactions. In decomposition reactions in our body, in respiration process, we will find this. We know that glucose, that is the smallest part of carbohydrate, that is C6H12O6, is going to be oxidized and forms carbon dioxide, water and heat. So this process involves the respiration process, and this is nothing but the decomposition reaction, because one certain substance is going to be splitted into more than one simpler substances. So in such way we can easily classify the certain part that is known as the decomposition. Fair enough? So far we have gone through several types of chemical reactions, and all the chemical reactions are permanent. So chemical changes are permanent. Such type of concepts have been generated. But trust me, chemical changes are not permanent. They may be reversible, and most of the chemical reactions may be permanent, but we don't know the proper logic to reverse the reaction. But we have some type of examples which can be reversed. And if the chemical reactions can be reversed, then the chemical changes are known as the reversible reactions. So over here, basically, if A and B recombine to form a substance that is AB, then AB can be decomposed and can form A and B individually. And such type of reactions is known as the reversible reaction. So the reversible reactions has a very special type of criteria. We have just told that. So the copper sulfate, we have discussed earlier in the video that copper sulfate is blue in nature, but if we heat such type of substance, then this will copper sulfate and water will be evaporated. As a result, this dust will be white, and this was blue. So this is a very good chemical changes which can be observed by changing their color. But in the reverse process, this will be again prepared. That means the anhydrous copper sulfate, if treated with water, then this will be copper sulfate, which is a crystalline structure and will have the color of blue. And such type of reactions are reversible. That means if we able to form two different substances from the actual one, then the two different substances also can recombine to produce the initial compound. And such type of reactions are very rare, but they can be observed. So in thermal dissociation reactions, this is a very important reaction. So first of all, this is nothing but a reversible reaction. So we need to know this is nothing but a reversible reaction where heat is involved. Okay, and next in one half it will show the synthesis, and in the next half it will show the decomposition. So all three type of characters are going to be displaced over here. So only in one part there will be a thermal decomposition. In the reverse way there will be synthesis, and obviously this is a reversible reactions where heat is involved. So three different type of characters are going to be introduced over here. So the most important and most preferable example over here, that is nothing but ammonium chloride. If it is going to be heated, then it will form ammonia and hydrogen chloride gas. Again, if we use ammonia and hydrogen chloride and we try to cool them, then they will form ammonium chloride, which is nothing but a solid. And in such type of reactions, two gases are going to be combined and form a solid one. So this is nothing but a reversible reaction. That is obvious. But over here for the first case, such type of reactions are known as the thermal decomposition, and second type of reactions is nothing but the synthesis. So both the reactions are going to be involved over here, but this is a reversible and heat is involved. So this is very important to realize the concept of thermal dissociation. Fair enough? Well, in the next type of reactions, that is known as the displacement reaction. And in displacement type reactions, the chemical changes are occurred when an active element is going to be treated with a compound and there is a displacement. That is the generalized formula. If we try to realize this, that is A plus BC. Imagine that activity of A is greater than B. So why we have chosen B? Because whenever we write any type of compound, and if that is ionic compound, then the left element must be cation and the right element must be anion. So as an example, if we try to highlight that NaOH, so Na is nothing but the cation and OH minus is nothing but the anion. So such type of bondings are occurred usually. So in displacement reaction, if A is going to be treated with BC, then if the chemical changes are occurred, then A will displace B. So the ultimate compound will be AC plus B. And this is a very pattern reaction to realize such concept. But the logical part is that before we progress further, we need to know a certain activity series of metals. So in activity series of metal, this actually states the actual reactive criteria of metals. So we have just written some amount of names, that is potassium, sodium, calcium, magnesium, aluminium, zinc, then iron, again lead, hydrogen, copper, silver, gold. So this is enough. But the reactive series is going to be decreased if we move from top to bottom. So if we move top to bottom, the reactive series is going to be decreased. This states the basic concept of the total activity series. How does it work? So imagine if we use sodium in water. So water has a cation part, that is H plus, and has an anion part, that is OH minus. So sodium and hydrogen, if going to be considered, then sodium is highly activated because hydrogen is placed below than it. So as a result, sodium will be able to replace the hydrogen and will form sodium hydroxide. And as it will replace the hydrogen in such type of reactions, hydrogen will be released as hydrogen gas. So if we try to balance the reactions, so this will be nothing but 2Na plus 2H2O, that is nothing but 2NaOH plus H2. Fair enough? So this is a very careful reactions of displacement. Fair enough? Again, if we try to realize such type of reactions with magnesium, so if we use magnesium in H2SO4, so in H2SO4 we know there are cations, that is nothing but H plus. In acid base salt we have just learned about this, and SO4 2 minus is an anion. So magnesium is placed on top of hydrogen. So as a result, magnesium is able to replace hydrogen, and this will be MgSO4 and hydrogen will be replaced. So basically over here, one active compound is able to replace another less active element, and such type of process is going to be carried out if we know the activity series. Until or unless we are able to memorize the activity series, then it is very difficult to perform such type of reactions, but this is very pattern reaction. Okay, in the next type reactions we will discuss on double decomposition, and double decomposition is nothing but a mutual exchange radical reaction. So what is mutual exchange radical reaction? To realize such concept, we need to consider first two different compounds where AB and CD both are ionic compounds must be considered. So they are ionic compounds. Fair enough? And if those are ionic compounds, we know the left element is nothing but cation. So in AB, A is cation, and in CD, C is cation. And if they react chemically, then the mutual exchange between A and C will happen. So basically A will be replaced by C and C will be replaced by A. So finally the product will be generated, that is CB plus AD, and such type of reactions is known as double decomposition. And double decomposition reactions can be classified into two different wings. Number one, that is nothing but precipitation reactions that we have just learned in the previous day, and number two, that is neutralization reaction. So we will basically highlight on the examples of each of type reactions because we don't need to know any furthermore from here. So the precipitation reactions, first one. So we told you earlier that if in silver nitrate HCl is added up, then it will form AgCl and nitric acid will be formed. And we told you earlier that in nitric acid AgCl is not soluble, and that's why the precipitation is going to be generated. And in neutralization reactions, this is nothing but an acid-base reaction. So if we use a certain acid and a base, then neutralization reactions will be observed. That is nothing but if we use NaOH and HCl, then what will happen? In HCl, H is the cation and NaOH, Na is the cation. So the mutual exchange between them will occur and the mutual exchange of the radical will form water and NaCl. That is, water and salt will be formed in such type of reactions. And in precipitation reaction, such type of thing has been happened. So Ag and H both are cations, so there is a mutual exchange between Ag and Cl, and that's why AgCl and HNO3 were prepared. Fair enough? Next type of reactions is known as the isomerization. Next type of reactions is known as isomerization reaction or the rearrangement of atoms. And trust me, such type of pattern reactions is not in our syllabus, but still we need to know about the concept of it. Over here, the certain compound is going to be processed with a certain interchange of molecular structure, and as a result a completely different type of compound is going to be formed. So no external substances are going to be involved, only one substance is going to be reformed their internal bonds and prepare a completely different compound. That is the exactly logic. If we try to highlight the organic chemistry, we will find several type of things of isomerism. So basically this is nothing but the compound that is known as ammonium cyanide. So ammonium cyanide, if is going to be heated up, then this will form NH2CO NH2. That is nothing but urea, which are a very useful fertilizer, and such type of reactions has not involved any other substances to perform this, and neither one substance is going to be decomposed. Only one substance has been used, and that they have rearranged their internal bonds and ultimately formed a completely different compound, and such type of reformation and rearrangement of bonds is known as the isomerization reactions. The next type of reactions is known as the polymerization reaction. This is also not in our syllabus, but still we need to know a basic concept. So basically in organic chemistry we will find such type of several reactions, and the most important thing that we use, that is polyethylene. That is, we know we use, that is polythene. So polythene is nothing but the short form of polyethylene. So polythene is basically prepared from C2H4. So C2H4 is an organic compound which is known as ethene. So ethene structures usually looks like this way. That is C double bond C, and both of the carbons hold two different hydrogens. But if we use infinite numbers of such ethylene compounds, then they will configure themselves in such way where the double bond between the carbons are going to be broken up and they form a single bond, and over here with a single bond they capture the adjacent ethene and construct such type of structures. And such type of bond formation capability is known as catenation. We will highlight on this topic further, but in such type of reactions two or more substances are going to be added up and form a linear structure to form a different type of compound, and such type of reactions is known as polymerization, and this has a longest branch, and such type of things only occurs in polymerization reaction. The last type of reactions is known as the redox reaction, that is oxidation and reduction reaction. Actually redox has two different full forms, that is red stands for reduction and ox stands for oxidation. So the reactions which involving the oxidation as well as reduction is known as the redox reaction. And first we need to know about oxidation. So The basic concepts will be discussed first, and then we will highlight the actual atomic concept. So oxidation can be taken place if the addition of oxygen is going to be occurred. That is number one, the addition of oxygen. This is very usual reaction. Basically, if we burn carbon in presence of oxygen, this will be carbon dioxide, and this is very obvious that oxygen is going to be added up with carbon and they forms the carbon dioxide. In the next hand, we will try to highlight that is the removal of hydrogen. So number two, the removal of hydrogen. And how does it happen? So if we try to highlight hydrogen sulfide and pass through chlorine, then we will find that HCl and sulfur will be prepared and sulfur will be precipitated. And in such type of reactions, from H2S, hydrogen has been removed. So from H2S, hydrogen has been removed and sulfur is going to be produced. So basically, hydrogen sulfide is oxidized. So this is very important. Hydrogen has been removed from H2S. That's why H2S has been oxidized, right? So in electronic theory, the oxidation is known as oil. So what is oil? Oil is a very short form to remember the total concept in a class. So oil means oxidation, I means is, and L means loss of electron. So in any type of reaction, if any element or substance lost their electron, the oxidation will be taken place. So how can we simplify this? So basically we need to simplify such type of reactions with a very conceptual manner. So we have just learned the activity series of metal, and over here we have seen that zinc has been placed at top of copper, because in the previous slides you will find such type of concepts. So if we use zinc in copper sulfate, so this will be nothing but a displacement reaction, because zinc has the higher activity than that of copper. So over here what will happen? The ZnSO4 will be formed and copper will be displaced, right? But how does it has been performed? Okay, now if we try to highlight the actual concept of the total reaction, then we will find a very interesting part. We know that CuSO4 is nothing but an ionic compound. So Cu has been placed as Cu2 plus and SO4 has been placed as SO4 2 minus. And zinc has no charge in it. So during the reactions, the zinc lost 2 electrons. As a result, zinc is going to be converted into zinc 2 plus and react with SO4 2 minus, and copper cation gets 2 electrons and becomes neutralized, and as a result zinc 2 plus and SO4 2 minus got an electrostatic force and they converted into ZnSO4 and copper is going to be displaced. And during such type of process, zinc has released 2 electrons. I repeat again, zinc has released 2 electrons. That is nothing but the loss of electron. So in such type of reactions, zinc is going to be oxidized. So that is very important reaction to realize that concept. So basically such type of reactions is known as oxidation, where the electron is going to be loosened. The last type of reactions which is going to be discussed right now, that is nothing but the reduction. So basically we will highlight the basic concepts initially and then the molecular concept. Okay, so reduction is the just reverse process of the oxidation, and as a result the removal of oxygen involves the reduction reactions. That is, in Q2 brick oxide, if we use hydrogen, and we know the hydrogen has the greater activity than that of copper, and as a result copper will be substituted by hydrogen, and as it is going to be substituted by hydrogen, it will be free as copper and water will be formed. Again, the addition of hydrogen will be also termed as oxidation. Well, if we try to highlight such type of reactions, then go for chlorine and H2S. If we try to follow such type of reactions, then we will find 2HCl and sulfur will be precipitated, and as a result, look carefully that chlorine is going to be added up with hydrogen and forms hydrogen chloride, and such type of reactions only happen because the addition of hydrogen is going to be conducted, and this is nothing but the reduction reaction. So in reduction reaction, either removal of oxygen will occur or the addition of hydrogen will occur. That is exactly opposite of the oxidation reactions. Now we will try to highlight the actual molecular concept of reduction. So basically the reduction has a different form, that is REG. So what is REG? REG stands for reduction is the gain of electron. So in different type of reactions, if any substance or radical gains electron, then that will be nothing but the reduction. So we need to highlight the same reaction which we have just followed in oxidation. So zinc plus copper sulfate, and over here we know the activity of zinc is greater than that of copper, so the exchange between copper and zinc will occur, and as a result zinc sulfate and copper will be generated. And now we will try to highlight the actual process. So zinc was neutral, but in CuSO4 copper was at +2 state and SO4 was at 2- state. So zinc has donated 2 electrons and converted into Zn2+, and whereas the copper has accepted 2 electrons, and as a result copper was neutral and SO4 2- was in the solution. So in the same way ZnSO4 was formed because due to the electrostatic force of attraction and copper was displaced. And such type of reactions in copper was accepting 2 electrons, that is the copper was gaining the electrons, and that is nothing but the reduction. So copper was reduced and it have achieved 2 electrons. Clear?